Hello Year 12, welcome to another video covering the chapter reviews. This one is the first one for chapter 2 review, starts on page 93 and covering networks. Okay, so let's have a look. Starting with the multiple choice 1 to 4. So questions 1 to 4 relate to this diagram here. And the first one is asking which of the following vertices has the highest degree. Now let's have a look where the vertices are. They're labelled A, B, C, D and E. There's our 5 vertices. And the degree comes from how many edges are attached to them, either going away from or coming towards. So the degree of A, 1 going away and 2 going towards, is 3. The degree of B has 1 going away and 2 going towards, so that's also 3. C has both edges going away from, so that's 2. Degree of 2. D has a degree of 2, and so does E. So of the choices here, looks like C, D and E all have 2 and B has the 3, so vertex B has the highest degree. How many edges are in the network diagram? So we're counting, we'll just take those away so they're a bit clearer to see. So edges, there's 1 here. 1 there, that's 2, 3, 4, 5, and 6. 6 edges. Okay. Next one's a fair bit more tricky and a bit more involved. Question 3, which is a valid path? Now, just to remind us what a path is, I'm going to go here and look at a path. Is a walk with no repeated vertices and edges, not repeated either. No repeated vertices or edges for a path. So let's go back. No repeated vertices or edges. Okay, let's have a look. So A, E, B and C. So okay, take that away again. Erase, so we can follow where we're heading. Okay, A, E, B, C. So starting with A, head down to B, that's okay so far. Sorry, that's not even right. A to E, oh that's right, it is right. A to E first. That's okay so far. E to B, good. And B to C is not possible because it's against the direction. So we can't do that one. Let's take those away for the next one. What about option B? C, starting at C this time, we go to D. That's all good so far. And D to A. Now remember, we're not allowed to repeat any vertices or edges. A goes to E. E goes to B. And B goes to A. So we've got a repeated vertice there. So that's not a path either. Okay, next one. There it is. So starting with C, goes to D. That's all good. D to A. Yes. A to E, so far so good. E to B, and B to C, again B to C is not possible. This goes against the direction. So the only one that's a valid path is D, but to make sure, just check, double check. A to E, and E to B. That's valid path. Doesn't have to cover every edge or every vertice, as long as each one is only covered once. And that's the valid path is part D. Okay. Now, let's get rid of that one again. Question 4. The sequence C, D, A, E, B represents. Now we're going to use this to check off. So let's go C to D to A to E to B. Alright, so edges cross multiple times. Well, only you know each edge is only done once. Vertices can be crossed multiple times. There's only once for each vertice. Yep. Yep, only once. It goes in and out. In and out. That's okay. That only counts as one. If that went back to there, again, that's be twice. So vertices are not crossed multiple times. Starts and ends on the same vertex. Well, no, it doesn't. So we've got to find something that we can't have no edges crossed, vertices crossed, and starts and ends the same vertex. Now, for these, it does not start and end on the same vertex, so it can't be a cycle, because cycle starts and ends in the same vertex, and this one does not. A walk can be anything, so it can be a walk. A path, no repeated vertices or edges, so it can be a path. Trail, a walk with no repeated edges, but vertices can be. The vertices are not repeated, and the edges are certainly not, so it can be a trail. But I'm now going to pick the most correct one. The one that all of this covers here. And because it says, got here the vertices and edges are only crossed once, we're going to go with the path. Vertices or edges, only once. So the path is the one. Thanks everyone.